Hey guys, so today I'm going to be running the Catalysis investigation establishing a baseline reaction rate experiment for you. So this actually requires 4 people, so do my best, okay? All right, so if you have your workbook, the instructions start on page 21, and there's a brief reading that you'll need to look over. And then I am going to be starting my experiment, my setup on page 23. So I'm going to set up the experimental apparatus as described. So we have a reaction chamber. We have an Erlenmeyer flask with a piece of tubing attached. And we have a graduated cylinder upside down that is completely full of water. Because the experiment that we're going to run today, we have this yeast solution, which has the enzyme catalase in it. And then we have our substrate, which is going to be hydrogen peroxide today. So whenever you combine the enzyme catalase and the substrate hydrogen peroxide, it's actually going to break this peroxide down into oxygen gas and water. So what we're doing today is we are going to be collecting the oxygen gas that is produced. Let me fix mine. All right. So I'm going to set it up by placing my reaction chamber. The tubing, I'm going to feed it up into my graduated cylinder, being careful that no extra air gets put up in here. All right, got that. Make sure there's no kinks in the cord. All right, there we go. All right. Now I'm going to measure out 10 milliliters of the hydrogen peroxide. All right, I'm going to place that in my Erlenmeyer flask, my reaction chamber. So what's going to happen is these two things are going to combine and oxygen gas is going to be produced. It's going to start bubbling and it's going to go through the tubing. It's going to go up into this graduated cylinder and it's going to start displacing the water. So that's how I can measure how much oxygen gets produced. So I'm going to put data on page 24. I'm going to put the data for you so that you can go along with this. All right, so lastly, I'm going to put 1 milliliter of the catalase enzyme in here. And I need to have all my supplies ready because like I said, this is a 4-man job. So I'm going to record how much gas gets produced every 30 seconds. Sorry, chaos this one. All right, I'm going to measure how much, if I can find a timer that works. Sorry, 1 second. Literally none of my timers are working this morning. User error. Okay. All right, back to every 30 seconds. I'm going to record how much gas is produced. So I've got it in this water bath so it can maintain a constant temperature. So we've got 10 so far, 15, 20, 30, 35, 40, 50, 60, 65, This reaction's happening really fast. Now it's starting to slow a little bit. We're at 80. Reaction's almost at a standstill now. At 85. $90. $95. All right, all the gas is out. So 100. All right, so it only took 3 minutes for all of this, for all 100 milliliters of oxygen to be produced. So this was actually a pretty fast rate of reaction. So I am going to make another video to show you how to calculate the rate of reaction. But basically what it is going to be, we ran out at 100 at 3 minutes. So we're going to divide 100 by how many seconds are in 3 minutes. So that's 180. So 100 divided by 180, following this formula down here at the bottom, you'll put that answer here. I'm going to also provide you the class average data, and I'm going to send graph paper down for you to graph this, okay? So, or you can graph it digitally and send that to me as well. So, I hope you enjoyed it. Oh, one thing I did not mention is I want you to think about why you think the reaction happened so fast and then it slowed down. So what happens is right now we have a whole lot of substrate and a whole lot of enzymes, and so the reaction can happen really fast, but the less substrate that's available, because the rest has been broken down, it's harder for the enzymes to find it, so it takes a little bit longer. So that's why it goes really fast and then it kind of plateaus out. All right.